Okay. All right. Here's a graph of some data. What's measured? Yeah.
The number of late deliveries over a period.
Okay. What's the trend? Going upwards. All right. I'm going to find out one of my biggest pet peeves when people make graphs. This is a horrible graph, and it is done completely wrong. Okay. Does anybody have an idea of why it's wrong? Because I guarantee almost everyone in here would have drawn this graph the exact same way. Yes.
Starting point or the scale?
Nope, actually both those are fine. You don't necessarily have to start at 0 because the way this was, it's 1 week, 2 weeks, so you didn't necessarily have to start at 0. And the scale, like you could go S6, 9. Yes, I know they don't technically start at 0, so I guess it could be kind of a confusing graph with that, but yes, they probably should have had a little break point in there. But nope, that's not actually the reason why this graph is completely wrong. A bar chart would have been a much better graph for this one and would have solved the problem that's here in this graph. Yeah. Yes. When you connect two things, that line has meaning. Think back to your algebra class. When you drew a line between 2 points, every other point between those 2 points was an actual answer to that graph. So are they saying that at 1.5 weeks, 7.5 people were late? No. The lines mean nothing. The only thing that means anything are the actual points. However, what does everybody do when they draw points on a graph? They connect them. Okay? Don't do that. Scatter plots are totally acceptable graphs. They do not necessarily have to have lines between them. The lines have meaning. All right, so just be careful when you're actually doing those little things with your lines. And like I said, everybody does it. It's okay. I understand that. Still bugs me. And one of the things that I always want to actually make sure and explain before while we're doing these graphs. What about this one? Is this one okay?
Well, the temperature can slide. So
Is it trying to show that someone's getting sick over time so the line does mean something?
Right.
That would be my thought.
So in this one, this line is okay. Okay? Because, which we're going to look at probably not today, is there's a difference between discrete variables and continuous variables. So temperature is on a continuous scale. Time is on a continuous scale. So in that situation, between hours 6 and 7, you did actually pass through every single one of those temperatures. Okay? It might not have been in that perfectly straight line because we didn't measure it, but if you were at 99.5 and now you're at 99.6, you had to have gone through all the other temperatures between those two temperatures. So that line actually has some meaning. Okay, so that one is okay. Where the number of late deliveries, I can't have 6.5. Okay, that's the big difference between there. And that's one of those things about when we're looking at measuring variables and when we're going back and looking at how we're talking about is the data measured accurately. You have variables that are continuous. You have variables that are discrete. We're going to talk about what those mean probably next class. So understanding where those fall will change how you can graph it, how you can do your calculations, what types of calculations you can do on it. So for example, we look at saying like the number of children. The average number of children in the United States right now is actually, I think it's at 1.9 children per family. The whole concept before was like 2.3. You can't have 0.3 of a kid. You can't have 0.9 of a kid. Okay, you can either have one kid or two kids. It doesn't work that way. So while they do the average on there, that's not a very good calculation to use because you can't have half of a kid. So we need to look at the calculations and the variables to make sure that it is an acceptable way to do those calculations. And this is a good example of two different types of measurements. Okay. All right. How are some ways that you can collect data? Yeah. Okay. Surveys, questionnaires. What are some other ways? Okay, observation. Is a survey an observational type data?
Kind of thing, just do it different ways. When you're talking to someone, one, I'm just looking at a road, seeing at cars, looking at cars.
Right. Okay. What are some other ways to collect data? Two main ways. Observation's one. The other one's an experiment. Okay. So with observation, that's where your surveys typically fall into because technically it's not, you're not doing something. That's the biggest difference between an observation and a controlled experiment. Observation, you're just collecting a bunch of data. The controlled experiment, you're actually doing something to influence a result. And then you're looking at how that impacts the answer at the end. Why are these important? Well, because when you're looking at different things, how you collect the data is different. How you measure the data is going to be different. How the results are going to be calculated will be different. Okay. So, okay, I was reading through. I was just looking at the book and the thing for it, and I can't believe they actually wrote this. It goes, there's many instances in which controlled experiments that would produce particularly appropriate data are not practical or would be unethical. Kind of like the example that I just said with testing on pregnant women. For example, medical researchers cannot randomly pluck an infant's liver out of their body in order to experiment with an artificial one. Like, how did the person come up with that example? But definitely unethical. So you can start to see like what would be a better way. Observation probably would be a better way to do those type of things. We can't experiment on those things. It's also why we do a lot of experiments on animals. Okay, they would do it on mice or pigs and those type of things to be able to actually come up with the information or a better way to do it. High school physics teacher wants to determine if there's any beneficial effect of studying calculus before taking physics. Would he do an observational study or a controlled experiment?
Observational,
Okay, what kind of data would he collect?
I guess, test scores or grades in general.
Yeah, that'd probably be a good one to do. Like collect it for the ones who took the calculus beforehand, figure out those, take the ones who are doing it at the exact same time. If any of you actually have to take like physics or anything of those classes, if you're going to take the calculus-based physics, make sure you take calculus before that. Don't take it at the same time. Take literally calculus first. I don't expect most of you to have to do that, but if you do, I would highly suggest that because your physics teacher is going to go faster than your calculus teacher will. So, all right. Okay. When we're collecting anything, we have two types of variables. we have a response variable and an explanatory variable. Okay. The response variable measures the outcome of the study. Okay. The explanatory variable explains the changes in the response variable. So, for example, in the one we just did, the response variable is the student's grades in physics. Because that's the end result, right? And we're going to look at how they did in the course. The explanatory variable will be whether the students took calculus before the physics. Notice the explanatory variable was not a number. Okay? I know in math we always think variables have to be numbers. They don't. Okay? Nowhere in this definition does it say it has to be a numerical value. Categorical data is a valid way to look at information. So a yes or no, or true or false, or a color, things like that. Those can all be explanatory variables that we would have to look at. How we collect and analyze those is a little different if it's not a numerical value. But that's an important way to look at it. All right. Suppose you're going to plant a new species of tomato that's been genetically engineered to increase yields. Okay. And I know everybody's like, oh, it's genetically engineered, it's bad. All the food you eat is genetically engineered. Every single thing you eat today is genetically engineered. You just didn't think about it because it's not done in a lab. Anytime they literally crossbreed things, that's genetic engineering because they're picking specifically to increase yield. So the reason we have so much corn and wheat and all that other stuff is because they've done these type of things. Totally off topic with this stuff. Does the new species produce higher yields? So, question. What is the response variable? Yes.
Yes, no, but you can also include how much.
Okay. So the response variable isn't the actual value that I'm writing down. So the response variable is what I'm testing that I want to get out at the end. So what about the new species of tomato? That wouldn't be the response variable. Response variable is going to be yield, how much I got out of it. Because if you think about it, what's the goal? The goal is to increase my yields, right? So my response variable is going to be the yield that I get at the end. How much of this tomato was grown? Okay. Your explanatory variable, that's the engineering. Okay. That's the genetic engineering because that's what I did to it to increase the yields or not increase the yields, as the case may be. Does that make sense? All right. Is there any other variables that can impact this? Or any other confounding variables that we could have? Yeah. Soil. Give me one. Soil's good. What's another one? Water. Sunlight. Anything else? Yeah. Huh? Types of fertilizer. Okay. Yeah.
Maybe whether there are any pests present.
Okay. How can we eliminate as much of those as possible? Yeah.
By controlling the environment that they conducted with so fewer of those. So each plot would be made from the same things, so we would reduce some of that.
So when you're looking at trying to do those experiments, it's important to understand those confounding variables. How can we eliminate or reduce those impacts on my study? So maybe those 16 plots are all right next to each other in a greenhouse where I can control the sunlight, I can control the water content, I can control everything. So it's all those things that we just mentioned are identical between the plots. Okay. So then we can determine how much they actually impact each other. So we eliminate those, but you need to understand what they are before you do study. So understanding the response variable, understanding the experimental the explanatory variable is important, but also understanding those other variables that I want to try to eliminate as much as possible is also very important. Does an SAT preparation course improve performance on the SATs?
Maybe.
All right. First question. What's the response variable? Yeah. So the SAT scores. Yeah, so the scores at the end. When you're picking a response variable, you want to pick something that will specifically tell you was it successful or not. So in this case, the SAT scores. Okay. What's the explanatory variable? The SAT prep class. Okay. Are there any other things that could impact the study? Are there any confounding variables? Yes.
Like if the student taking it to begin with is already knowledgeable of those things.
Okay. So prior knowledge.
Yeah.
Yes.
Like test anxiety, I don't know. It's
Test anxiety. Okay. Yes.
Anything relating to concentration, like lack of sleep.
Okay. Anything else? So how can I create a study that would give me the information I want and eliminate as much of that as I possibly can? So actually, let me ask one question before we look at, is this an observational study or a controlled experiment? Why?
like you're having them do the expectation score.
Right, I'm doing something. Okay, I'm actually doing something. That makes it an experiment. Okay, so how would I conduct this experiment, eliminating as much of the confounding variables as possible and get a good result out that for or against the preparation class? Yes.
Everyone would have to be present. Class.
Okay. So sometimes there's something known as a control group and then the treatment group, right? Would that be a good way to do this study? So let's say I take this half of the class and I'm going to give you that it's the SAT prep class. This half of the class, you're not going to get the SAT prep class. So you'd be the control, they'd be the treatment group. At the end, I test the results. Would that be a good experiment?
Probably not all sleeping the same, eating the same, doing the same type of studying.
Okay, so the confounding variables there, I don't solve those issues, right? Okay. Basically are the same.
Be sure, like, they get a certain amount of sleep or eat a certain meal, so they're all working off the same fuel, so to speak.
Okay, so I could solve the sleeping issue. Well, it's a bunch of teenagers and people, so probably not. But we'll assume that I could solve the sleeping issue with the control of the treatment group and the food group, because that's actually like when you're in high school. That's why a lot of times they'll feed you breakfast before you do the SATs and stuff, where they normally don't. They'll give you snacks and stuff like that. That's why. Okay, so we can kind of eliminate that. But what's the one big thing that there's no way for me to eliminate between the two groups on the side? what was the confounding, so sleep and stuff like that, that was one of the big confounding variables. What was the very first confounding variable that was given to me? I think you told me in the back. Yeah,
Was it attendance?
nope,
It was like prior knowledge.
right. So how smart you are to begin with, right? If this side of the class is really smart and this side of the class isn't, and I give you guys the prep class, they can still beat you. So I would somehow have to completely understand that beforehand, right? And mix them all up and everything else. And then even if I send a kid that's really smart through the prep class, it might not actually make much change, right? So you can start to see how this is not an easy problem to solve sometimes. Okay. But you can see how all these things that we're looking at really do have an impact on that actual study at the end. Do you have an idea on how I can do it?
Yeah, you could test them, give them an SAT, and do the class, and then do another SAT. So you have like a benchmark at the beginning versus after the class.
Correct. And that's actually how most of them are done. That's actually why most teachers nowadays will give you a pre-test, do all the work, and then give you a post-test and say, look, I've improved your scores. So it's called a before and after setup. So basically, everybody takes a test. I get your scores on it. You're great. I then go through and do the treatment. And then at the end, you guys can take the test again and see if your score is improved. However, there's one thing that can impact that. How many of you took the SATs? Because I know this prior to like COVID, everybody in here would raise their hands, but that's not always the case anymore. How many times did you take it? Okay. On average, if you take the SATs the second time, your score will automatically go up between 100 and 200 points. Just from the first time taking it to the second time of taking it. With nothing changed in between. Why?
They're already taking the test and to know what it is now.
Yeah. What else?
I guess you would know what to, not prior knowledge, but you'd understand what they're asking out of you.
Understanding the test alone helps you improve your score. Somebody said test anxiety was a big issue. If you've already taken it once, you know what to expect, your anxiety level drops. Your score goes up. You're less freaked out. Instantly, your score will go up. So even if I do the whole test before and test after, I still need a control group that doesn't do the actual class. Because I need to make sure that my score of my prep class goes up even more than the average of the other class. Okay? So you can start to see how, like, this is why what most people see is the headline at the end and the report. Where if I'm going to create this prep class, I'm going to turn around and say, I guarantee a score increase of 150 points on everybody who takes my SAT prep class. Okay? And you're going to see that and go, your parents are going to say, wow, that's great. Sign me up. What did I just tell you about taking the test the second time? How do you increase the score? So if you're not looking at the study and the information on how they did it, all you look at is that headline, is the title, you lose a ton of information. Okay? So going through this class and learning about all this stuff helps you dig deeper into those studies so that you can understand what they did, why they did it, how they did it, how they got their data, how they measured their data. Okay? Because that's going to help you determine if the headline is accurate or not. Or are they trying to sell you something that, while true, I didn't lie, I guarantee your scores are going to go up by 100, 150 points. It's not wrong, but is it my study is it my new great idea that did that? Okay. That's the piece that's important. So, and that's where they claim that you can lie with statistics. it's not that it's a lie, it's just not giving you all the information you need to understand what's going on. Okay. And that's why we say you have to read beyond the headlines. And we see today, like every the clickbait. It's like, oh my God, that's you click on it. They give these headlines to make you click on them. Okay. And then 9 times out of 10, what the headline was is not exactly what the actual thing is, but most people don't even read past it. They're just looking at the headline and sharing. Go beyond that to understand what's going on, which is important. What's a placebo? Have you ever taken something and automatically start feeling better? Even if it does nothing, you feel better. Most of the old wives' tales fall into this category. A placebo is something that is typically known as a fake treatment. However, it's designed to get that result. Okay. Kind of like I just did with the 100, 150 points. Like it's there for some other reason. So when you're doing a actual, like real medical study, if I'm bringing you in and I'm saying, I'm going to treat you for allergies, I'm going to solve your allergy problems. I've got this new drug to take care of all allergy problems. You come in every day, I give you the pill, you take it and go about your business. If I'm telling you right up front that this is going to solve your allergy problems, what is in your head? You're going to solve the allergy problems, right? You're going to have that there. So you're going to see some relief. You might be a little less itchy, right? Or you might sneeze a little less. It's like, but was it the drug? That's where that placebo comes in. So the goal is to say, okay, the people who are taking the placebo saw a 5% decrease in allergy response. The people that were taking the actual treatment saw a 12% drop in results. Okay, or an allergy response. So then odds are it was probably between like a 5 and 7% decrease in allergy response due to my drug as compared to the placebo effect. Does that make sense? So that's where those placebos and stuff come into play, is that you need to have something there to make sure that you can eliminate basically our brains telling us we're better. So if you don't know you're taking the placebo, that would be known as a blind study. Does anybody know the other one? Not you. You answered them all. Anybody else? Otherwise, I'm going to let him answer. Yes. It's a double-blind study. What's the difference? Who's the other person?
Oh, and the research.
The researcher doesn't know. That's the big thing. Why does that matter if the doctor doesn't know? Yeah. Again, it's that effect, right? If I know you're not taking the drug, I know there should be nothing changing with you. So I'm not treating you better, or I might treat you differently, or I might collect different information about you because of what I know is going on. By not knowing, by having that double blind, I'm going to be able to, I would treat everybody the same because I don't know who's getting it. I'm going to collect all the same information. So we go back to the other one, like if I know you're taking the placebo and you tell me, oh, I'm sneezing less, I'm like, well, yeah, that's fine. I'm like, I might not write that down because I know why you're not. It's like, I know that has nothing to do with the drug. That's just your brain. So it's like, I'm not going to write that down. But if I don't know, I'm writing everything down, collecting all that down. So this way I can do that connection. So your double-blind studies are exactly that. All right. let's do a few problems. Okay, read the problem. All right, we're going to skip the first one because the phase doesn't really make much difference. Is this an observational study or a controlled experiment? Why is it a controlled experiment? Okay, so you're doing something. That's the big difference when you're looking at these. Is observational, you're not actually doing anything. You're just collecting data. The experiment, you actively are involved in the process. Okay, there's something you're doing. So in this case, we're giving subjects peppermint lace chocolate or peppermint lace placebo. That looks like chocolate. And I'd be very upset. All right, what's the response variable? Migraines. Okay. How many migraines they got? What's the explanatory variable?
Which type of chocolate they got?
Chocolate. Right? They're studying to determine if chocolate is causing the a migraine. What group is the treatment group? Well, they're both migraine prone subjects. Which one's the treatment? That's so right. So in this case, we're testing the chocolate, right? So that's the drug in this case. So the treatment group is the one who's getting the chocolate. The placebo group is the control group, the ones who are not getting it, to determine if there's a difference between the two. I had a friend whose daughter was getting constant migraines. Migraines are very hard to actually determine like what's causing them, and a lot of it is food allergies. Her food allergy turned out to be red number 5. And they found it because of Skittles. Like they had to write down everything she was eating. And then it turned out to be that when she ate Skittles, but not all Skittles, it had to be the red Skittles. It gave her a migraine. So, and actually just come find the red number 5 is actually now banned in the United States. So it won't be in your foods anymore. So, but yeah, it was like, that was the cause of the migraines. But chocolate actually is a big impact as well. So, good. Nope, we're not going to go into that one today. We'll do that one tomorrow or Monday. Let's get another problem here. That's going to take us a while, and I don't feel like confusing you right now. Let's look at this one. All right, read the little heading. Those allergy pills aren't helping. Must be in the placebo group. All right. So why is this a controlled experiment? I don't know why they asked it that way, but
They're controlling the variable, and also at the end it says there were no significant differences on the test between two groups, which also shows that they are acting upon it, and therefore it is a controlled experiment.
so almost. So we have a control group because we have the sibling group, but that's not what makes it a controlled experiment. What is the difference between an observation and the controlled experiment? What's the one key difference? They're doing something. They're actively changing a situation, right? So in this problem, what is the action that they're taking? And separating two groups is not an action.
Is it that they're taking the siblings as well?
Nope, that's separating. That doesn't count as an action.
Or the asthma?
It's the asthma drug. So the one group is getting a drug. That's the experiment. That's what makes it a controlled experiment. Okay. Now, that's what they're testing. And they might not be physically giving it to them as part of this experiment, but because one group is getting it, and then the group of siblings that doesn't have asthma is not getting it, that's the experiment that they're doing. That's between the two pieces. So that's how you're getting that treatment group and the control group. The treatment group is getting this medicine, even though technically it's not part of the actual experiment. All right. What is the explanatory variable? So explanatory variable is what is the cause for the result?
Whether they were being treated with a drug?
Yeah, it's that drug, right? That's were they treated with it or not treated with it? Because they're trying to determine if this drug is impacting academic performance. What's the response variable? This one might be a little tougher. Okay, skip to enough.
Academic performance.
Almost. On the test. They gave a test. So the response variable is the academic performance on that test. Okay. So because academic performance can be measured a bunch of different ways, they specifically gave them a test to determine their achievement. So they probably gave it to them before and then down the line to see if there was any major change in that. We've already talked about, is there a control group? So could I have done this as an observational study? Why?
If it's two different results, then I think
So remember when we're thinking about when we're setting up these studies, it's that confounding variables, right? What are some of the variables that could have impacted this that they were able to eliminate by making it a controlled experiment? By having that control group and having the treatment group. There was a very key piece of information in this problem and how they picked their kids.
they have a non-academic setting
Right.
with genetic.
So that was able to eliminate the nature and nurture debate, right? Like they're all in the same, they're in the same family, they're getting the same treatment, those type of things. Um, they had the same basic genetics. So that actually is probably pretty hard to find because a lot of times asthma runs in the family. So it's like finding one that has one sibling that has asthma and the other one that doesn't. That'd be kind of difficult. I think the only thing that better they could have done is if they found twins, 72 pairs of twins that did it. Could have eliminated a lot of things. But that's the big difference in this. If it was done as an observational study, they would have just collected a bunch of data on all these kids, and then they would have had to decide what was going on. They wouldn't have been able to give a test because that would have then ended up being part of the experiment, those type of things. So it does change our outcomes a little bit in that respect. Let's do. Let's do this one. All right. This will be our last study of the day. All right. Is this an observational study or a controlled experiment? Yes.
Observational,
Why?
I would say because they didn't like, it's not very structured, it doesn't seem like they like did like a survey or find out. At least that's descriptive.
Okay. Anybody want to make an argument for this being a controlled experiment? Okay, make your argument.
The only reason I think that is, the measurements of the food they eat, like it's pretty exact at being a cup or less than a quarter of a cup, which means they had some kind of control over the serving size, I guess.
Okay. Notice there's not always one right answer. I can accept that. Hawks would like one right answer, but everything's not always cut and dry. And this one, I can see both directions of this one. I probably would say it's observational because I think they actually did this as more of a survey. They probably just asked them these couple questions and then collected some data in there. But nowhere in the problem does it say they didn't do that. So I could see it either direction. All right. What's the response variable? Yes. Yeah, you go.
Okay. Would it be like, the percentage of stroke?
Yes. So the response variable is the percentage of strokes and heart attacks, or technically the number of strokes and heart attacks at that point. Okay. What's the explanatory variable? Yeah, the beta carotene that they're eating. Which is the treatment group? Not quite. Although that was my first thought when I first read this problem too. And then I read the last sentence. That changed it a little. Yes.
Assuming it's an observational study, would there not be?
So
They are,
remember, the only thing I said was that an experiment means you're actively engaged in the process. In an observational study, I can still have a treatment and control group. I'm just not controlling what's going on. So even if it's an observational study, I'm still comparing two different groups. So the difference between the two is how much they eat. Yeah, so the treatment group is the ones who eats the cup of it. The control group would be the ones who eat the quarter of a cup. Originally, when I read it, I was looking at it as the 87,245 were the treatment group, or the group, and the general population is the control group, because that's what I'd be comparing it against. But then I caught the last line where it says who consumes a quarter cup of it per day, and that actually makes it a little bit different. So, okay, good. All right, so we have done 2.1. So in Hawks right now, you can actually do the homework assignment for 1.1 through 1.8, the chapter 1 assignment, and the assignment for 2.1. Next Monday, we'll do 2.2 and 2.3. Okay. So what is the one major thing you have to do before Monday? Log in to Hawks. Okay. Get into the class on Hawks. Thank you. Have a wonderful weekend. I will see you on Monday.
Oh, thank you.
Yes.
I'm sorry, I just
No, you're
signed up
fine.
to this class last minute.
Okay.
But I did get the actual physical textbook.
Okay, you just need the code.
Okay, yeah,
So as long as there's a code in it, you're good.
okay.
And all the information for my class is on bakersmathclass.com.
Okay, do you still record it?
Yep. I missed the beginning, but it's recording.
Okay, and then did you record Monday
did.
or, okay, all right, and then it's on.
Baker's Math Class. Yep.
Okay, all right, thank you.